Hello, welcome to Ekidel. We are with train future civil and structural engineer. My name is 𝔼𝕜𝕚𝕚𝕝 and I am your instructor. Today, I'll be showing you a structural design of a high-rise building, as you can see here on my screen. So looking at this right now, this is a structural design of two high-rise building, and the two buildings are unequal. The reason why I say they are unequal is because the first one you are seeing here is a 30-story building, and the second one you're seeing here that is shorter is a 21-story building. Okay, now when you have this kind of building that is unequal, what happens is that the weight of the buildings are also not the same. As you can bear with me that this is a 30-story building and this is a 21-story building. As you can see from the structure tree here, you can see that 30-story building here. Now on this right now, since this is a 30-story building, you can bear with me that the weight of this structure, which is the 30-story building area, and the area of this place also will be different. All right, the 30-story building here will be more heavier compared to the 21-story building here. So when you have this kind of building, what you have to do is to provide a seismic joint, or you call it an earthquake joint. Yeah, the one that you are more familiar is simply called expansion joint. All right, but when you have uneven structures side by side and they are of different level, and in that case they will have different weight of the structure. All right, so in that kind of thing you will have to provide a seismic joint. All right, now the purpose of that seismic joint is to do is to take care of the of the shear, right? Because since the weight of the structure is different, that means that the rate at which the 30-story building here will settle will be different from the way this 21-story building here will settle. All right, because of their weight. Yes, every structure has what they call initial settlement. Right, that is fine. Yeah, they have what they call initial settlement or premature settlement, right? And what you are meant to avoid in a structural design is what they call is to look out for permanent settlement. All right, it is that one we design for. All right, so every structure has initial settlement. So in that case, what happens when this structure begins to settle during the stage of initial settlement and all that, which is not likely noticed in a structure. All right, now knowing that this is a 30-story building and this is a 21-story building, if you don't provide an earthquake joint or a seismic joint, then that means that the rate, since they are being joined together without a joint, you can see that the that structural element that joins these two buildings together, that means around this region here, around this region, let me just zoom out area, around this region, around this area, they will have to suffer. All right, it will have to suffer. Yeah, this is basically yeah, when you're designing for high-rise building for a 2018 version of Protastructure, it tries to load up. But compared to when you are designing for 2022 version, as you can see, let me just open that. Yeah, this one doesn't happen that way. So I will also always urge people to migrate to a higher version of Prota. Yeah, you can see that this is not lagging. Can you see that this one here is not lagging? Yeah, so even if you design for any kind of story, it will not cause lagging to your structure. All right, compared to how 2018 always lag. Okay, on that. Well, let's just use that for now. Okay, so as I was saying before, again, I was saying that based on the weight of two different structure, you have to provide a seismic joint or earthquake joint. Now the reason why it's called a seismic joint is because it is purely different from the one expansion joint or concrete joint. All right, expansion joint doesn't get to the foundation, it stops at the superstructure, but seismic joint gets directly to the foundation. That's why it is quite different from expansion joint. And also the width of a seismic the width of a expansion joint is 25 millimeters to 50 millimeters, but the one that is more common to use is 25 millimeter. But when it comes to seismic joint goes all the way to 200 millimeter width. of the joint. Okay, so you can see that it is quite different from expansion joint, and the way you treat or design or the way you treat a seismic joint during the construction stage is different from the way you also treat what expansion joint and all that. Okay, so right now this is a structure we are designing for, and right now we are about to apply the wind load and other loadings, because we have not yet loaded the structure and all that. And also, sorry for that, it will also carry seismic load, and because this is in earthquake fault line and all that. So with that, we have also applied seismic loading to this structure, and the code we are using for this design is Euro code, which I will show you just now. So right now with this, I will then navigate to this place here, but before then, yeah, so I'll then go to analysis here and then begin to load my structures and all that. So I'll come now and then click on this place here that says bidding analysis here. Now from there, I will then move on to the place here. You can see that we have seismic parameters loaded here already. Then we'll now go to the place that says what, loading combinations here. Now on this, now the next thing we'll do is now click on what, you can see that there is no loading here. We then click on what, loading parameters here and all that. Now from this, now I'll just go here and then click on this place that says what's horizontal loading. All right, you can see that seismic loading is what already checked, which we have also loaded every seismic parameters and also the earthquake what magnitude, okay, and all that. Then we now want to apply what, wind load. I will then come here and then click on what, national loading, and then wind load, and the next thing here I'll click on is what, temperature loading. All right, and all that. Okay, so with this now I'll then click on what, OK here. Now on clicking on OK, now we have now applied wind load to our structure, but we have not yet applied the wind data. Okay, so we are now going to apply what, the wind data now by clicking on what, OK here first. Now on this OK, now this structure now have now known that we are about to apply what, apply the wind load. Okay, we then go here and then click on what, wind and story load. Okay, so on this place now I have done many video about wind load, so I will not spend time explaining wind load here and all that. So I would advise, if you are new on Ekidel, you can watch other videos that we have explained a lot about wind load. Okay, so right now I will then click on this place that says what, wind load calculator here. Okay, now it will show up this right now. The next thing I'll do is to do what, impute my wind to impute what, my wind speed parameter, which is what, 30 meter per second and all that. Then based on the values I have, then I will then go and then all this place here, I have done many videos about all this. So this is actually the he height, which is actually let me say the height of the obstacle that is before your structure, which will help to prevent the which will help to counter the wind speed before the wind speed now hits your structure. Okay, knowing that wind also is also a factor, is also a load to your structure. Okay, so the height, basically I'll just leave it at 50, but actually the maximum height of the structure around the place we are, around the region where this building you're seeing here is meant to be built, is 11 stories. So let's assume that the height of the story is 33 meters, that is around 33 meters. So I'll just put it right now 33 meters as the height of the obstacle before my building. Okay, then the distance between that obstacle to the site where this 30-story building is to be sited is not well cleared, so I'll just leave it as what, default. But if you know, you just come and do what, impute that. Okay, but I'll leave it now as default, and the mean sea level as default, and this also as default. Now this heat height also I'll leave it as what, cliff. I know that's fine. Then leave it as upward wind, and then the next thing that is important is to choose what is to pick your what, category. Okay, so the category right now, this is basically on category 4. okay, category 4, that's where this structure falls in. That's basically area with covered vegetation or buildings. Yeah, there are buildings surrounded around the place where this building is to be sited, so I'll choose that to be this. Okay, so I'll come down and then click on what, okay. So make sure you don't make mistake while choosing this. Make sure you verify the terrain around where your building is to be sited, okay, and choose the right one, because if you choose the wrong one, then it will affect the structure, okay, because what you are doing here, what you're doing in the design is to do the reality of what's going to happen in the real life, okay. So make sure you get all the parameters that's going to happen in the real life along the terrain or region where that building is to be set up, so you can now go and do what, apply that into your design, okay. That's fine. So right now, then click on what, okay here. I know that now. If you're new on Ekidel, I would like you to do what, subscribe to Ekidel, and if you're an old member, thank you for subscribing. Now we have introduced a new membership on Ekidel, knowing that before we have paid membership, we have premium video membership, and we have Ekidel mentorship membership, and now we have now introduced a high-rise building membership, okay. So if you are interested in high-rise building or not, that you can join our what high-rise building membership, because on that place we post videos only about high-rise building and tell the principles to that you have to take into consideration when you are designing for high-rise building, okay. Then if you are an upcoming engineer like students and also some professional engineers here on Ekidel, I would advise you you just join our Ekidel, so you join our premium videos, okay, because premium in the videos we post here on YouTube is different from the one we put in as a premium video. As you can see in most of our videos, you will see that they are titled what, they have a tag on it that says members only, so you can see that those videos can only be watched by the members. So, and those videos are well detailed and well explained, okay, and all that. So you can find yourself to join that membership and then begin to watch our exclusive videos, which is quite different from that. Even if we try our best to explain in detail when it comes to the video we are posting here on free version of our channel, but in the premium version we try to explain a lot, because basically we are not dealing with what duration in that area, but when it comes to this free version of YouTube, we are dealing with what duration. So with that factor, we will not be able to explain much things and all that when it comes to the free version of our channel. But since we have much time, we have to explain a lot on that area for the premium version. So it is always advised to watch premium videos when you are watching any channel, not only Ekidel, all right, any channel at all. Always try to look at if they have premium videos where you can pay to watch. It's always good to do that, because they explain much more compared to the one you just see on the channel and all that, okay. That's fine. So with this now, let's now move on to the place here that says what, building category, which is here. Now, yeah, this is a reinforced concrete, so I'll just pick what, yeah, that's fine, and then come here and do what, say what, apply, okay. Now once I click on OK, just now we have just applied the load into the load of the wind into the structure, okay. I'll then click on what, OK here. Now on clicking on OK, now we have just applied the load of what, 30 meters per second wind speed into this structure. That's fine, okay, that's okay. So right now you can see that we have done the loading, we have done seismic loading, which I've done before, and then the next thing now, if you want to know more about seismic loading, you have to begin to join our what, high-rise building, okay, because that's where we have videos on seismic parameters, how to design structures in terms of seismic load, okay, that's fine. So right now we have done with loading. The next thing now we'll do is to do what, is to do and go and choose what, our materials, okay. So on those places now, when you are designing for a high-rise building, it is advisable to choose a higher grade of what, concrete. Don't always choose smaller grade of concrete, because grade of concrete affects your design of your structure, okay. That's fine. So with this now, you can see that the lowest grade of concrete here I have here is grade 20, as you can see that. So I'll click there and then choose a higher grade of 25. Some people can choose a higher grade of 30, which is nice. but I'll choose a grade of what 25 for the structure, and then come here and then click on what apply to all member and all that, and then click on what okay. That's fine. So in this software also, you can choose different grade of what concrete for different structural member. For example, I can come and choose a grade of concrete of 30 for columns and walls, and then come and choose a grade of 25 for concrete for concrete beams and for slab. Okay, that's fine. Okay, then right now we then move on to the what grade of what steel, okay, which is your characteristic strength of what steel. So I will click on this right now. You can see that we have several grades here. Now this building I'm designing for is in what Canada, so they have good grade of steel up to 500. So I'm going to pick my grade of steel as what 500. But if you're designing for countries like African countries, I would advise you pick either 460 or 410, because you don't trust the grade of steel that is in the market. Okay, so always choose lower grade for African countries. But if you're dealing for advanced countries, but even if it's an African country, but you are sure that the company manufacturing this reinforcement will be able to manufacture a higher grade of steel up to 500, then you can go with that. Okay, but for now I'll go with this. Okay, that's fine. So with this now, I'll then apply to what apply to all members and all that. Okay, that's fine. Then I'll now click on the word this. Now we are not designing for pre-stress slabs, so I'm not going to pick this pre-stress. I know that I can show you that later. Then I'll then come and then do what okay here. Now you can see that we have not changed what all our grade of steel. Then our rebars right now, for the rebars. Now for the rebars now, the next thing I'll do for the columns now, I'll click on rebar diameter for column and all that. Now for the rebars now you can see that because we choose a higher grade of steel, we are seeing what our bar notation as what T. Okay, that's what H. Sorry, H. If you choose 460, you will see T, and if you choose 410, you will see Y as your bar notation. Okay, that's fine. So right now I'm going to choose I'll just uncheck all this. I'm going to start with grades. I don't want to use 16 for my column. I want to start with grade 20 because this is a high rise building. So 20, 25, 32 seems to be for me. I will uncheck that and just pick only these two and then say what okay, that's fine. And then on the walls now, I'll then come here and then click on what the same value. I want check this, uncheck this, and uncheck 16, 20, 25, and then uncheck this. Okay, that's fine. And then I'll click on what okay. Then our unchecked is 32 is unchecked, yes, okay. Then on the beams, for the beams now, I'm going to check 16. So I'll uncheck this, uncheck, and check minimum to be 16, and then they have 18 in Canada, so I'll check also 18, and then check 20, 25, and uncheck 32 is too big. Okay, that's fine. And I'll click on what okay. Then for my slab now, for slab, I'm going to check what diameter 12. Okay, so I want check everything here and check only 12. Okay, they also have 14, so I will check 14 for slab, and then uncheck all this right now. Okay, and then that's fine, and I'll do what okay now. Okay, then on the links, we don't have rib slab on this structure, so I'll not check rib slab. Then go over to what link here. Now on the link now, I will check what diameter 10 and 12. Okay, 10 and 12, and then uncheck all that ones here that seems to be here. Okay, that's fine. So with this now, then go and then do what okay. Now for the links now, the reason why I check that 12, not really that it will use them 12, it's going to use them 10, but it's always good to check what minimum and maximum. So I'll check my 10 to be minimum and then 12 to be maximum, because if I check 8 to be minimum, it can use 8 for design, which I don't like using them 8 for my links. Okay, I like using 10. Okay, so with this now, I'll then go and do what and okay it now. Okay, and then okay, and then okay again here. Okay, then now come here. Now let me now show you the codes we are using for this design of the structure. If I click on parameters right now, and then on parameters now, and then go to codes here, you can see the codes here. You can see that the concrete design code is what Eurocode UK, and then this also, and this also, and then for the earthquake is what Eurocode 8, which is the best for what SenseMe design. And I'll come here and then click on what okay here. Just say okay, that's fine. So with this now, you can see that we are done with what our loading. Okay, the next thing now, let me just close. Next thing now is now do what, is now go and do what, now go and design for this structure. Okay, now when you're designing for this structure, now let's just done lagging. Yeah, it's a lag. Once you pass up to 10 story in 2018, you see that you're beginning with what, with that begin to lag. Okay, and all that. Well, the lagging doesn't really affect the structure, but what happens is that it will take more time. If you are meant to spend like 45 minutes or 10 minutes in your design and your design stage, it can take up to 1 hour because the structure is massive. Okay, that's what it means. Okay, that's fine. Okay, so let me just walk you through to the plan view of this structure right now. You're seeing here the plan view. Let me just go to plan view here. Okay, plan view, and then walk you through all the plan views. Okay, and that this is the plan view of story 2, and then for the story, let me just go to story 8, which is typical from story 5. It's typical up to the upper floors. Okay, so from story 5 now is quite typical, as you can see here. Yeah, this is how it looks like. And then I quickly turned off my grid lines, yeah, just to have a clearer view. Okay, so let me just turn on my grid line just now. If I turn them on now, you can see the grid lines are being turned on. Okay, yes, that's fine. You can see the grid lines here are being turned on. Yeah, but let me just go and turn it off because I don't want to turn them on. Yeah, and all that, because they look so they are much, and during the detailing I can remove the ones that are not necessary. Okay, and all that. Okay, let me just turn that off again. Okay, that's fine. And then okay, so now right now it is now off. Okay, as you can see that. So this is you can see how I reinforced the walls at the center of this place, and also we also have lifts here, and this place here is our stair hall, which is the staircase area, and all that. The same thing happens to this other side too, but basically this is the one that has the 21 story, this other side here, and this side has the 31 story here. Okay, and all that. So then we walk on to the back to the 3D view now. Okay, and on that, then let's now begin our structural design of this building. Okay, that's fine. So now we are going to then go to click on what, on the analysis, but don't forget that it will try to save because we have done changes. Okay, so let's just save first before now begin to what, design for this structure. Okay, so basically on our next video we will be performing the structural design of this structure, which we are going to post in less than, let's say 8 days from today, and that we are going to post the structural design of this structure. So by the time we start the design of this structure, then we will now move on to other things we have for today, because we are about coming in with other structural designs. Like if you check on our screen, just let me just show you on our screen now, we are trying to design a linear structure. Okay, so I'll be showing you how to model a linear structure. For example, let me just show you that on our design right now, and this will be listed among the high-rise building classes. Okay, so let me just show you that right now, so you can see that, you can see this structure here. Yeah, this structure here is, let me just let's just be loading. Okay, yeah, so this structure right now is leaning. Can you see that? It's leaning at a 75 degrees. Okay, can you see that? But if you look at the front, at the approach, it appears straight, but from the sides they are all leaning. Okay, now the question will be, you are asking, what when the way the structure is leaning affects how the people that are using this structure? No, it not affect, as if you can look at very well, all the slabs here are quite what, straight. Okay, and let's now walk you to the section of this structure. You can see that from the section, yes, all the columns and the structure is leaning at the angle of what, 75 degrees, but you can see that the slabs, okay, the floors are all quite straight. Okay, they are not leaning. Okay, so the people using this structure will not have the feeling that this structure is leaning. It is only you that is outside that will see that this structure is leaning. Okay, that is the powerful when you have a good designer and also a good structural engineer, then you will be having amazing structures and all that. Okay, so we will be performing this design on this for this, beginning from the structural framing and all that, and up to the structural design, and that video will be attached to to the high-rise building membership for the users on the membership. Okay, that's fine. So on this now, let's now go back to this. Yeah, I think it is done saving, so I use that one just to finish up the saving of this building. So then we will now walk on to the this place here, and then click on building analysis. And now on this place, I'll have to use two methods here. I'll use the FE floor analysis, which we are going to use what load chase down. But before then, it is advisable to perform your building analysis first before you can now move on to the finite element method of what analysis. Okay, that's fine. So I'm going to show you these two on our next video, okay, which I'm going to show you these two methods on our next video and all that. Okay, so stay tuned and all that. Now if you have stayed up to this end, I will say that if you have not subscribed to our channel, please consider subscribing. And also, if you're a student or you are also working in a company, try to recommend your colleagues and also your friends what is happening here on Ekidel. And if you have any question regarding what I've done today, I would like you to drop your question down on the comment section, and we will reply you, and we will try to reply you ASAP. Okay, so thank you so much and God bless you. We love you, and then bye for now. Okay, then bye. If you want to learn structural design, then Ekidel is the best for you. By clicking the link, you are already one step ahead. Don't miss this offer. Enroll now.